So in our first session, we looked at what we call quantitative and qualitative data. We said quantitative is simply numerical data that can be measured or quantifiable, whereas qualitative data is the data that is numeric, that is non-numeric. When we're dealing with type, we're dealing with codes, we're dealing with nationality, or the quality of something. So in short, when we're dealing with numbers, that is quantitative. When you're dealing with non-measurable data, that is qualitative. So quickly, 5 marks, help me identify the following parameters and state whether they're qualitative or quantitative. So the eye color, what is eye color in terms of data?
Qualitative.
So eye color is qualitative, correct?
Yeah.
Then we go to age of an individual.
Quantitative.
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 QT. Number of square meter of a house.
Quantitative.
Quantitative. About marital status.
Qualitative.
Qualitative. Level of education.
Quantitative.
Pardon?
Qualitative. Level of education.
Qualitative.
Quantitative. Oh, okay.
Is it quantitative or qualitative?
Qualitative.
Qualitative. All right, so anyone behind on this before I proceed? How about one's NRC number?
Quantitative.
Quantitative.
How about a barcode of numbers on a commodity?
Quantitative.
Quantitative.
You are wrong on both. It's qualitative. So I mentioned in the preamble to say sometimes you may have codes or numbers. You can't measure somebody's NRC. Those are just a representation, a number plate of a car. All right, those are just codes. That is qualitative data, but in numeric form. But the age of an individual can be measured. The weight of an individual can be measured, but you can't measure one's NRC. Are we together?
Yes.
Does it make sense?
Mm-hmm.
All right. So now we go to what we call ungrouped data. So in ungrouped data, we're given a sample. So we'll be asked to find the mean. We'll be asked to find the median. We'll be asked to find the mode. We'll be asked to find the variance. We're asked to find the standard deviation, the coefficient of variation, okay, and to identify the outlier. So this is what? 25 marks. So I will give a dummy example, then I'll ask you to do that question as homework quickly. So you're given a box of figures, 1, 2, 3. So this is 2, this is 4, this is 20, this is 3, this is 4, this is 5. So the first thing you need to do is to rearrange your data. So to arrange the data, you start from the smallest. So we have 2, then we have what? 3,
3,
then we have what? 4,
4,
then we have what? 4 again, then we have what?
another 4,
We have a 20.
20.
Then we square them.
You've omitted the 5.
We omitted a 5. All right.
Mhm.
So omitted a 5. So I'll put a 5 here. So here 5 and what? 20. Then we square them. 2 times 2, 4. 3 times 3, 9. 4 times 4, 16. 16 times 16, 4 times 4 again, 16. 5 times 5, 25. And 20 times 20 is 400. So let's total on both sides. What are you getting when you total on both sides?
10, 15, 48.
Divider. So x is 20.
Okay, sure. You add all these plus the 20 itself.
Oh, 38.
38.
470 on x squared.
470. And what is our n? How many are they?
6.
6.
26.
Correct. So how do we find our mean? Anyone? The mean is given by what? Summation of x over n. What is the sum of x? 38. And what is our n? 6.
6.
So what do we get when we divide the two? .33. Then how do we find the variance? The symbol for the variance is s squared, because the sum. All right. So that's a symbol. So we're going to have x squared minus summation of x to the power 2 over n and everything over n minus 1. So substitute what we have there. What we have as x squared?
470. Is that?
Hello? Hello?
Hello, you can see the tabulations here. So x squared is 470. Then this is x to the power 2. So 38 to the power 2 over 6. Then everything over n minus 1. So the starting point is what? This point here, 38 squared divided by what?
Yes, 6.
Divided by 6. What do we get? When you divide this 6, what do we get?
240.
240, yes, 0.66
2.66.
or 67. Then you subtract that one from 470. What are we getting? 229.33. You divide this by 5. So our variance
5.86.
45.86 or 45.87.
7.
Then when you square root it, it is called the standard deviation. So what is the square root? Standard deviation is simply the square root of the variance. So this is called standard deviation.
Standard deviation is the square root of
The variance. So 45.87. What is the square root of this?
6 point
6 point what?
77.
77. Okay, any questions at that point?
standard deviation. You
Okay.
said that S plus DV, is it?
No, standard deviation. This is just some, I'm just simplifying. It's called standard deviation. Standard deviation. Just using abbreviations. STV sometimes. We're square rooting this to get that.
Okay,
Exactly.
so this S2 or S2 is the
variance.
The variance.
Yes. So in short, the standard deviation is when we square root the variance. In short.
Okay,
Yes.
square root the variance. So which we get 45.
Square root of
5.83.
Yes. The square root, yeah.
70.
Yes.
So our standard deviation is 6.77.
Exactly. So this is our standard deviation. Okay. Then we calculate our CV. CV stands for coefficient of variation. So CV, the formula is standard deviation over the mean times 100. So what is our standard deviation?
6.77.
6.77. And what is our mean?
Our mean is 6.33.
6.33. And what are we getting when you divide that?
1.06.
1.07. So this is our coefficient of what? Variation.
Coefficient of variation. Okay, so
after finding the standard deviation,
variation.
Yes.
The coefficient of the variation, does it have a definition or it's just that?
The coefficient of what?
Variation. Yeah, I'm saying, does it have a definition or it's just like that?
No, there's no need of that, but you can, it just measures how much the mean is deviating from the expected average, but you'll not be asked to explain it. Okay, so now we go to the range. Range is the difference between the highest value and the smallest value. So the maximum value of x minus the minimum value of x. So what was the maximum value of x? 20. What was the minimum value of x after rearranging here?
2.
It was what? 2. So what is our range? 18.
Okay.
Is that clear?
Yes.
The mode is
So
another. The mode is the most frequent. So which one is the most frequent number from our tabulation? So the mode is the most frequent.
Isn't it 4?
most frequent is 4, yes.
So our mode is what? Is 4, the most
4.
frequent. Then we have what are called quartiles. We have the first quartile, which is Q1. It is a quarter of n plus 1. We have the second quartile, which is a median. It is given by half of n plus 1. And we have the third quartile, which is Q3. It is also called the upper quartile. It is 3/4 of n plus 1. Now these ones give you positions. If you get position number 1, if you get position number 2.25, you round off to the nearest figure. This one is the same as what? 2. If you get position number 2.75, you round off to the nearest whole number, which is what? 3, yeah?
Mm-hmm.
But if you get 2.5, it's in the middle of this same number 2 and the next number. So it is 2, the second position, plus what? The third position, you divide by 2.
Yeah, so I'm lost.
I'm lost.
I'm saying the quartiles, if you get a number like 2.25, these numbers must be definite. So you round off to the nearest whole number, it is the second number. How about 2.75? You round off the third number, all right? Okay? All right, together.
Colleague, I have a question. Like, is there a way maybe you can start with a definition of a quartile itself? Like, what is it?
All right. So a quartile, these are simply quarters, all right? If you have 1, 2, 3, 4, okay? The first quarter is this, it's like 25%. The quarter is simply 25% of the distribution. Then the third quarter is simply 75% of the distribution. And the second quarter is 50%, it's half. Okay. So we had our numbers here. Our smallest number was what? 2, 3, 4, 4, 5, and what?
20.
So
20.
2, 3, 4, 4, 5, and what? 20.
20.
So this is position number 1, number 2, number 3, number 4, number 5, and number 6. So according to the formula, quartile 1 is simply a quarter of n plus 1. So let's calculate. Our n is how many? 6, right? So what is a quarter of 6 plus 1? So what is a quarter of 7 in short? A quarter of 7 is what? 1.75. So what position to the nearest do we get? When you round off this one, what position are we getting?
2.
2. So the second number. So which one is the second number when we go to this distribution here?
Second number is 3.
3, good. So this is our first quartile. This is 25% of the distribution. Then when we go to our third quartile is 3 quarters of n plus 1. So our n plus 1, 6 plus 1 is 7. So 3 quarters of 7, what do we get? 5.25.
5.25.
So which one is the nearest number we get? When you round off? Just what? 5, right? 5. So which one is the fifth position?
5.
5 itself. So this is our Q3. Then you are remaining with a median, which is Q2. So how do you find Q2? Q2 is simply half of n plus 1. So our n plus 1 is 7. What is half of 7?
2.5.
So whenever we find a 0.5, we get the number plus the number that follows it. So 3 plus what? The third number plus the fourth number divided by what? If we found 7.5, it is the 7th and the next number, which is 8. We found 19.5 in 19th and 20th. Found 100.5 is 100 and 101. So this is 3.5. So it's 3 and the fourth number divided by 2. So what is our third number?
2, 3, 4.
4. And our fourth number?
4.
Is also 4 coincidentally. So 4 plus 4 divided by 2. What do we get? Still 4, right? So we get the average of these two numbers here. So 4 plus 4 divided by 2 is what?
It's 4.
Yes, it's 4. Listen, don't get 1, 2, 5, 9, 20, 21, 1, 2, 3, 4, 5, 6, and 30. These ones are already arranged in order. What is our n here? 7, right?
6. Oh, 7.
7. So quarter 1 is a quarter of n plus 1. So 7 plus 1 is what? 8.
8.
What is a quarter of 8? 2, right? A quarter of 8 is what? 2.
2.
So what is our second number there?
2.
2. So this is our Q1. Then our Q2 is half of n plus 1. Half of n plus 1. Our n is what? 7. 7 plus 1 is 8. What is half of 8? 4. So which is the fourth number here? 1, 2, 3,
9.
4. 9. So 9 is our what? Our Q2.
Q3. Oh, 2.
We go to Q3. Q3 is 3 quarters of n plus 1. So n is 7. 7 plus 1 is 8. 3 quarters of 8 is what? 6. So which one is the sixth number? You count them. 1, 2, 3, 4, 5, 6.
21.
21. So this is called our third quartile. So we also have what is called the interquartile range. The interquartile range is the difference between the upper quartile and the lower quartile. So Q3 minus Q1. What is our third quartile in this case? 21. What is our first quartile? 2. So 21 minus 2 is 19. So you need to think and think and think real good. This question is very easy. You just need to tell your brain to think.
Collins, I think I missed the IQR. Sorry, I received an incoming call.
The interquartile range
What is it?
is a range of the quartiles, the difference between the upper quartile and the lower quartile. So the difference, Q3 minus Q1. So 21 minus 2 is 19. The semi-quartile range, semi means half. It's simply half of the range, half of the interquartile range. So half of 19 is what? 9.5.
So the semi-quartile range is simply half of the interquartile range.
Exactly.
Okay.
So let's go back here again to understand here. From our initial question here, we had 2, 3, 4, 4, 5, and 20. How did we find the first quarter? A quarter of n plus 1. Our n was 6. 6 plus 1 is 7. A quarter of 7 is 1.75. So we can't get this number, but round it off to the nearest whole number, which is 2. So that's how you found our 3 there. The second number there is what? 3. So our 2 is a position, not the answer. But the actual answer here is what? 3. That is our first quarter. Our third quarter is 3 quarters of n plus 1. 3 quarters of 7 is 5.25. So here we get the position, which is position number 5. So position number 5 here is coincidentally 5. So our Q3 here is what? 5. Then we go and get our second quarter, which is half of n plus 1. Okay. Any questions? Any questions?
Nothing. Sorry, the last part you said, what was the last part you just said just now?
To find our second quartile, it's half of the quartile range.
Yes.
Mm-hmm.
Just 3.5.
3.5. When you find a 0.5, it means half of the average. So 3.5, you find the third and the fourth, you average the positions there. So 3 and the position number 4, the answers there, add them and divide by 2. All right. If the average was 4.5, would have gotten the fourth and the fifth number, divide by 2. So 4 plus 5 is 9, divided by 2, 4.5. If it was 5, would have gotten the fifth and the sixth. You add them. So this is 5 plus 20, which is 25, divided by 2, 12.5. All right.
So if the number was or didn't have a point, we just pick the number.
Yes, exactly. So quick, can you remember how did you find our mode as 4? How did you find this 4 as a mode?
It's the most frequent number.
Most frequent, correct. The range, how do you find the 18?
We subtract the x max and the x min.
The highest minus the minimum, correct. Then how do you find the median? The median is what? The second quarter.
Median is the second quarter?
Yes. So half of n plus 1. So n was 6. 6 plus 1, 7. Half of 7 is 3.5. So the third and the fourth, add them and divide by 2. All
So
right.
you said the median is
Half of n plus 1.
n plus 1.
The lower quartile is a quarter of n plus 1. The upper quartile is 3/4 of n plus 1. Now,
Collins.
uh-huh.
Okay. I have a question on the second quartile, the median, is it?
Yes.
So when we sum up the two numbers, for example, in this instance, we got 4.
2 plus 4 divided by 2.
Yeah. So if, for example, the two numbers there, the average there, was giving us a decimal figure.
Yes, it's okay. If
Oh,
you
it's
had
okay?
4
Okay.
and 5, you add 4 plus 5, which is 9. Half of 9 is 4.5.
0.5.
Yes.
So Collins, this rule, the one for 3.5 or 4.5. So let's say first, second, third quartiles, if they had 0.5.
Yes, exactly. You still follow that. As long as it's a 0.5, it's a position of that number and the following number. Good question.
No.
All right.
Okay, so like in the sense of anything above or below we don't consider unless just is for 0.5.
Yes, if it's below, if you have 6.25, you get a 60. 6.75, you get the upper limit, which is 7. But 0.5, you get the average of 6 and 7.
Oh, okay. So if it's above 5,
you get the upper limit.
You get the upper limit. So in this case, when we did the first quarter, which we had 1.75.
Yes, that's how we got 2. We rounded off the upper limit.
The upper limit.
Then this is 5.25, the lower limit.
5.25, the lower limit.
Yes.
So that's 1, 2, 3, 4, 5.
Which was 5 coincidentally.
5 coincidentally. So then this one, the one you said upper limit, the one we found 1, which meant it's just 2.
Yes. The second position. So our second position was what? 3. So the difference between the second quartile and the third quartile is called the interquartile range. So 5 minus 3, what is our interquartile range?
5 minus 3, it's 2.
Yes.
Okay. So I think I've grasped it. So since we had 1.75, we got 3. But if it was 1.25, would have gotten the same 2 or anything less than that?
Exactly. Now you get it.
Okay, so on the third quartile, like the way we had 1.25, 5.25, which position 1, 2, 3, 4, 5. The 2.5, it meant we get the 5 itself.
Itself, exactly.
What if it was 5.78?
Yes, you get the 6.
The 60th number, which would have been 20.
Yes.
Okay.
Exactly.
So as long as it's not above 0.5, we don't get the next number, but we get the exact number.
Yes.
Okay. I think that's a bit clear.
Then now you go to what we call a box whisker plot. So a box whisker plot, it's called a box whisker plot. It helps you identify the outlier, the odd one out. An outlier is an odd one out. For instance, you're in a home, all of you are blacks and you have a colored in the house. That colored is an outlier. So it includes 5 things: the minimum value of X and the maximum value of X. What was our minimum value of X? It was 2. Our maximum was 20. Then we go to our Q1, Q2, and Q3. What was our Q1?
Q1 was 3.
3. Our Q2?
2.
Right. Q2 was
4.
So our Q2 was 4 and our Q3 was 5. So 2, 4, and 5 there. So the interquartile range, the difference between these two was what? 3. Okay. This was our interquartile range. So you multiply 1.5, it's standard, to this 3. What is 1.5 to this 3? You get 4.5.
Mhm.
The interquartile range was 3. You multiply 1.5 to the 3, you get this number 4.5. So 4.5, you add it to the upper quartile. The upper quartile. So 4.5 plus 5, we get what? 9.5. Then this 4.5 is subtracted from the lower limit. 2 minus 4.5 is negative 2.5. Any number outside those ones is called an outlier. So 20 is outside the limits, it's called your outlier. I repeat, after finding your interquartile range, just multiply it by the standard number, which is 1.5. You get 4.5. So this 4.5 will be added to the upper quartile and will be subtracted from the lower quartile. So when you add 4.5 to the 5, you get 9.5. So here, the X max is outside, so it becomes an outlier. So the lower limit, we subtract the 4.5, it goes to negative 2.5. So meaning this 2 is within. So meaning there's no outlier on this side, but there's an outlier on the right-hand side. So this is how we get our 25 marks. And we end our class here. Your homework will simply be to do this question thoroughly.
Collins.
No questions, please.
Just repeat that thing.
I'll send the video on the group. You will need to go through this and find the mean, find the median, and all the other parameters. Take your time to study. This is 25 marks. Have a good day. Thank you so much.
Collins.